Recall that neutrons are those particles at the nucleus of an atom that don't carry a charge. Now, when you're interested in calculating how many neutrons are in an atom, you need to remember two separate facts. That neutrons and protons are, first of all, much heavier than electrons, and thus they make up the bulk of the atomic mass, but also that they're roughly similar in their size. So in order to calculate the number of neutrons, then you subtract the atomic number, which is just the number of protons, from the full atomic mass once you've rounded that number. For example, looking at the entry for carbon from the periodic table, you see the atomic number, the number of protons, is 6, and that the atomic mass is 12.01. Now, in order to calculate the number of neutrons, we would first round that atomic mass to 12 and subtract the number of protons, or 6, giving us the number of neutrons equal to 6. And again, remember that the protons and neutrons are roughly the same size, and because they're so much heavier than electrons and make up the bulk of the mass, then we simply have to subtract the number of protons from that total mass to roughly estimate the number of neutrons. So take a second here to pause and answer the following question. How many neutrons are in the nucleus of phosphorus? Okay, so phosphorus, as we see, has an atomic mass of 31 when you round that 30.974 up to 31. And then to calculate the number of neutrons, you would subtract the number 15, the atomic number, or the number of protons, and you get a neutron number of 16. So 16 neutrons in the nucleus of phosphorus. It's important to note here, too, that for many of the lighter elements, the number of protons and number of neutrons is often the same, but that is not always the case, as in phosphorus. Isotopes are different types of atoms of the same element that differ in the number of neutrons. So remember, the thing that keeps an element's identity is that atomic number or the number of protons. Neutrons and electrons, as we've seen previously, can change. Now, the atomic mass number, written as a superscript to the left of the element symbol, equals the number of protons plus the number of neutrons. So sort of like the atomic mass, the rounded atomic mass. You'll see it written in this way to tell you which isotope of the element we're talking about. Okay, so what is the atomic mass number of each of these isotopes of hydrogen? Remember that the atomic mass number equals the number of protons plus the number of neutrons. So we see here in these three different isotopes of hydrogen, each of which differ in their neutron number. Protium would have an atomic mass number of 1 because there's simply one proton in its nucleus. Deuterium would have an atomic mass number of 2 because it has one proton and one neutron. Tritium would have an atomic mass number of 3 because of those 2 neutrons in addition to its one proton. So again, notice that these are all hydrogen atoms because the identity is given by the number of protons, the atomic number, which is equal to 1 in the case of hydrogens. The neutrons and electrons can change. Okay, so again, take a moment to pause your video and ask yourself how many neutrons are in each of these isotopes: 18 oxygen, 15 nitrogen, and 14 carbon. Okay, so how many neutrons are in this isotope of oxygen? Recall that atomic mass number 18 to the upper left of oxygen is the total number of protons and neutrons in this isotope of oxygen. And then recall that we're going to subtract the atomic number, the number of protons, from that atomic mass number, giving you a total number of 10 neutrons in this heavy isotopic version of oxygen. If you look at the periodic table, you see that the atomic mass printed there is 15.99, which, recall, we would round to 16 and subtract the atomic number from to get a total of 8 neutrons in that isotope of oxygen. But we've specified a special case here with the 18 oxygen. Okay, so heavy nitrogen, 15N, we would look at that atomic mass number of 15 and subtract the atomic number of 7 to get a total of 8 neutrons in this heavy nitrogen, 15N. And then in heavy carbon, 14 carbon, we would subtract the atomic number 6 from that atomic mass number of 14 to get 8 neutrons inside heavy carbon.